Good evening, everyone. Thank you for coming, and welcome to the Minnesota Zoo's Our World Speaker Series. My name is Tyler. I'm the Community Program Supervisor here. Great to have some of you here. It's kind of interesting how in the wintertime we're always talking about these nice summer activities and some talks. In the summer we're talking about polar bears, so it makes sense. Why not? I suppose I should say as well, if you're here for volunteer training, you're in the wrong room. Sure. Well, thanks again for coming as well. I always want to say thank you to the Clean Water Lane Legacy Amendment for making this free for all of you. So it's a nice opportunity, awesome opportunity. So yay to that. And I also want to say that it's one of those, this topic tonight is one of those topics that I find thoroughly interesting. Anytime you read about climate change, it seems like polar bear is the species that everyone rises to the surface as this is the example of what we need to talk about. So I was really happy that Seth could come out and talk tonight. So hopefully you enjoyed it as much as I know I will. So no pressure, Seth. But so I will take this time to introduce Seth real quick. Seth Stapleton is a postdoctoral research fellow at the University of Minnesota. Over the past several years, his work is largely focused on the development and implementation of new techniques for monitoring polar bears. Hopefully we'll see a lot of cool slides about that kind of stuff. Which includes aerial surveys and remote sensing tools such as satellite imagery and the drones. Do you get to pilot the drones yourself?
I wish.
He's also collaborating with organizations including the government of Megafauna. Oh, so close. And Greenland Institute for Natural Resources developed to evaluate biology or genetic mark recapture. Seth also dabbles in some sea turtle stuff. It's a little stray, but pretty cool to me. He runs a long-term hospital study in Antigua, West Indies. See, that's why he does polar bears and then the West Indies. Right?
Minnesota splits the difference.
Okay, very cool. He earned his undergraduate degree from the College of William & Mary, a Master's of Science degree in Wildlife Ecology from the University of Georgia, and completed his PhD in conservation biology at the U in 2013. So without further ado, I'm going to introduce Seth Stapleton.
Thanks very much. Thanks very much for the kind introduction there. As mentioned, my name is Seth Stapleton, and I am a postdoc at the University of Minnesota. I'm specifically in the Department of Fisheries, Wildlife, and Conservation Biology. And today what I'd like to talk to you about is polar bears and climate change, specifically what we know, what we don't know, and how we got here. Okay, so polar bears, this is of course the scene you think of. Well, I wanted to provide a little bit of background for how I got here. I came to the University of Minnesota in 2008, and before I started working on polar bears, this is what I was doing. This is a beach on a little island called Dominica in the West Indies. And at the time I was studying sea turtles, so leatherback sea turtle, hawksbill sea turtle in Antigua, and those are green sea turtle hatcheries. And I love sea turtles. I continue to do quite a bit of sea turtle work. But at the time, I felt like I wanted a little bit of change of pace. The sea turtle world had gotten a bit too political for me. And I said, okay, let's see if we can find something else where maybe the politics aren't so strong. Unbeknownst to me at the time, you know, hindsight's 20/20, but I ended up taking advantage of an opportunity to come and work on polar bears. And this is really one of those instances where we were stepping out of the fire and into the flame. And you know, 10 years ago, I could never have imagined that I've had the opportunities that I have specifically to work on polar bears. But I'm very grateful for it. Again, I'm very much looking forward to speaking to you a little bit today. Okay, polar bears. When people think of the Arctic, they tend to think of these vast sea ice landscapes, these very harsh climates. And they might also think of this guy right here, this polar bear that's wandering across the sea ice looking for its next meal. It's in search of its next prey and perhaps the next ring seal it's going to eat. And polar bears are really iconic species. They are an icon of the North. They've captured the imagination of people worldwide. You don't have to live in the North to appreciate how fantastic polar bears really are. And a lot of Southerners really appreciate that as well. They're also an iconic and a very culturally important species in the North to the Aboriginal peoples. Polar bears are also a sea ice obligate. What do I mean by that? Well, they depend on sea ice for various aspects of their life history. They use sea ice as a hunting platform. They use sea ice for reproduction, for movements, all different components of their life history depend on sea ice. So we've got an iconic species that is sea ice dependent. And we're also, I'm guessing everybody in this room is quite familiar with climate change and what's going on right now. So this is a graph that depicts the September average monthly sea ice concentrations. And September is typically when the Arctic reaches its sea ice minimum. So that's essentially what we're representing here. And we go from the 1970s up until last year, 2014. What you see is a pretty precipitous decline in the extent of sea ice over that 3+ decade period. Okay? So we've got iconic species dependent on sea ice and large-scale changes in the sea ice habitat this species relies on. What we've really come to have at this point is the poster species that symbolizes climate change and whatever political debate might be involved in that. So when we think about polar bears now, some of you might think of an image like this. The polar bear that's waiting on that remnant ice floe, waiting for those last sections of ice to break up before she has to begin that long and arduous swim to shore. Hopefully she'll make it before she drowns. Or she'll be looking for the next piece of ice, okay? So I should say with this particular picture though, that this bear was in great condition. She wasn't that far from land. I took this picture. She was a few kilometers off. This is a nice expansive land. And we actually saw her not because of her, but we saw her because of the seal she had just killed around the corner. Okay, so this is a fat and happy bear. She's doing just fine. The image is powerful though. That's also a powerful image. Okay, so I took this photo as well. It's unpleasant. That's kind of the point, right? We have a bear that appears to have starved to death. It's very emaciated. You can't make a connection to climate change. Maybe there's something else going on there. It had a disease. It had some other injury that made it predisposed to dying of starvation. But it's an unpleasant image. It's very powerful. This is the type of imagery that is often invoked when we think about polar bears and climate change. That's a very powerful image too. Has anybody seen this picture before? Okay, this is a pretty famous picture, and I'll explain why in just a second here. So it's a beautiful shot. You have the polar bear, the ice floe, flat glass of water. It's a little bit better than my shot back here. I like my picture, but this one perhaps is a little bit better. So I'm going to have to step out here because I wanted to read this to you. So this was published in the journal Science. And for those of you who aren't aware, Science is a very prestigious journal that publishes the most important findings worldwide in the general field of science. Okay, so this is published with an article entitled "Climate Change and the Integrity of Science." We are deeply disturbed by the recent escalation of political assaults on scientists in general and on climate scientists in particular. All citizens should understand some basic scientific facts. There is always some uncertainty associated with scientific conclusions. Science never absolutely proves anything. Cool, I have no issues with that. I agree. There's a little problem though. This copyright just popped up here, okay? It's ice.photo.com. That in and of itself is not a problem. This is a problem in my mind. This image is a Photoshop design. This is published in the most prestigious journal in the world for science, an article about the integrity of science. This is an image of a Photoshop design. Polar bear, ice floe, ocean and sky are real. They were just not together in the way they are now. Oops. In my opinion, that's a pretty big mess up there. Okay, so what happened with this? Well, Science actually had to issue a retraction for this. Okay. Due to an editorial error, the original image associated with this letter was not a photograph, but a collage. The image was selected by the editors, and it was a mistake to have used it. The original image has been replaced with an unaltered image photograph from National Geographic. So when we have an article about climate change and the integrity of science, and we're essentially publishing a fake picture to go along with that to illustrate our point about the integrity of science, there's a little bit of a disconnect there. Okay? So this is the type of out there right now. So we have one that says they are on the verge of extinction. They're not going to be around for much longer. We had better do something else. We have the other side that points to things like this and says, polar bears? There's no problem with polar bears. They're doing just fine. There are lots of polar bears out there. They're healthy right now. What's the big deal? And there's a lot of information out there. If you do some quick Google searches, you can find all kinds of supporting documentation that point to this. Okay? So it's really difficult for me and for the general public to try to reconcile what's going on here. What pieces of information should we actually be looking at? Part of the issue is this. Yeah, it's a polar bear, but it's a pretty darn cute polar bear too. That's a little cub. And that's what we might call a charismatic megafauna. Megafauna is a big animal, charismatic. It's a pretty cute little guy. Polar bears, up close and personal, they're fantastic animals. They're beautiful, very powerful weapons. They're also really darn cute. And a charismatic megafauna is a term that is used to kind of encapsulate this whole idea that a species can evoke an emotional response in people and get people pretty excited and pretty fired up about that species. Now, polar bear is not the only charismatic megafauna. You could also throw in critters like tigers and lions and panda bears, elephants, rhinos, sea turtles, dolphins, those big animals that maybe they look like our dog, maybe they're more closely related to us on an evolutionary scale, maybe they're more intelligent, something that really evokes that emotional response in people. So this complicates things a little bit. But the bottom line is there are all these different types of information out there right now, and it's really difficult as a member of the general public, I think, to disentangle reality from myth. How do we really know what's going on? What is fact? What is fiction? How are polar bears actually doing right now? Okay. So that's really what I want to talk about today. How are polar bears doing? That's going to be the first thing I talk about. What do we know and what do we not know about polar bears and polar bear conservation right now? And now what do we not know is a pretty darn important part of this as well. Number two, what are some of the challenges that we face in polar bear science and management? I already mentioned the charismatic megafauna that makes things a little bit more complicated, but there are several things that are quite unique, in my opinion, to polar bear science and polar bear management that complicate things and make our jobs as biologists and the jobs of managers quite a bit more difficult. And number three, okay, so polar bear science and polar bear How many polar bears are there today? 5,000? 10,000? About 25,000? Or about 50,000? 5,000? Anybody? Okay. 10? A few more? 25? 50? Anybody optimistic? Okay. It's about 25,000. So let's take that with a grain of salt. There's a lot of areas where we don't have any good, reliable information from. But I think 25,000, the official polar bear specialist group estimate is about 20 to 25,000. I think it's probably closer to 25,000, maybe a little bit more than that. But we'll call it 25,000 for our purposes here today. How does this compare to historical levels? Is it less than we had 50 years ago? Less than. About the same. More than. Gotcha. It's a lot more than we had 50 years ago. Okay, and again, you have to take that historical estimate with a grain of salt too, because that is based on anecdotal information and stories from explorers and hunters and community members way back when, in the 1960s and 70s. Okay, but it's pretty widely accepted that about 50 years ago, we think there were roughly 5,000 to 10,000 polar bears in the world. With a grain of salt, today we think there are about 25. So that's quite an increase. Okay. Now, I didn't include this in my little quiz here, but does anybody have any ideas as far as what's going on? Why did that number shoot up like that? What's the mechanism there?
Protection.
Sorry?
Protection.
Protection? From what?
Hunters.
Yeah. Better harvest management.
Yeah.
There was a 1973 agreement on the conservation of polar bears, And one of the big issues there was reining in harvest and setting up a framework for monitoring polar bears and conserving polar bears in the future.
If the ice sheets are decreasing, wouldn't that also make them so they have easier access to the seals when it comes to land?
They primarily hunt seals on the ice, so they rely on that ice as a hunting platform.
Yeah, so wouldn't the decrease in ice over time also lead to an increase in population because food's more available?
The ice dynamics temporarily might change how well suited the particular habitat is for polar bears, but on the whole is widely attributed to improvements in harvest management. Okay, so we've got improved harvest management. Are polar bears hunted in North America today? True or false? True. True? False. Couple false? True. How many? Any ideas? I didn't include this one, just for fun. It's a big number. In Nunavut, Canada has about 2/3 of the world's polar bears. In Nunavut, annually harvested about 400 to 450 polar bears. Why? Because it's part of the Nunavut Land Claims Agreement. It's an Aboriginal right, so those are native harvests. Yeah. So it's just part of the culture. And so there's quite a bit of polar bear harvest that goes on, but it is very well managed, yes.
Part of the culture argument is also used for whale hunting. What's it?
Between polar bears and whales?
Between polar bear hunting and whale hunting. Like, why is everybody up in arms about whale hunting other than the fact that they're intelligent? Presumably more so than bears.
That's a good question. I don't know. But I mean, I will say polar bear hunting and harvest is very well managed. And I'm not going to make a statement about whale harvest because I don't know enough about it, but the polar bear harvest in Nunavut, which is where most of my work is done, is very well managed. And I'm kind of stealing my thunder here a little bit, but that's okay. Harvest is not an issue for polar bears in North America. There are other places where unregulated harvest can be an issue, but in North America it's very well managed.
You had it.
Another question? Yes, sorry.
Is it limited?
The harvest?
Can hunt?
Yes, it's highly regulated. It's regulated in terms of numbers that can be shot. It's regulated in terms of males versus females can be shot. Youngsters are off limits. It's regulated in terms of who can hunt as well.
Could I go hunt polar bear?
There are some communities that facilitate sport hunting. So you, as a non-Aboriginal person, could go and hunt a polar bear in the north.
Is it by lottery?
You can purchase it, and it will cost you a nice chunk of change to do so. And then there are specific regulations associated with how you can go out and harvest that bear as well. Now, if you wanted to try to bring that bear back to the States, you're going to have problems because it's now listed under the ESA as a threatened species, and there's also the Marine Mammal Protection Act. So you could go up there and hunt a polar bear, shoot a polar bear, but it's going to stay in Canada, or you're going to have to take it somewhere else. It can't come back with you to Minnesota. Okay, so what's the primary conservation issue? I already answered this question by saying that harvest isn't a big deal. Climate change, not trying to trick you there. And then finally, okay, I'm showing a picture of polar bears on land here. Is that alarming? Should you be concerned about that? True. Anybody think you should be? No, that's completely fine. There are parts of the world where this is the normal thing to do. Those are two big adult male polar bears. You can see they're nice and fat and healthy guys. Kind of a little fun aside, the male bears, when these seasonally ice-free populations, when they are confined to land like this, they do tend to pair up or aggregate in small groups. And it's only the males that do this, and they call them fraternities. So I don't know if they're playing poker or what they're doing.
That's why they're fat.
Yeah, they're big, healthy guys. Okay. So that's our little polar bear quiz. And I mentioned before, I think there's a lot of misinformation out there. So this is a book that was forwarded to me actually just this morning by a family member, just to get my take on it, because they know I work on polar bears. So we just went through some basic information here about polar bears. Overhunting will eradicate polar bears before climate change can. That's from a press release excerpt from this book. Obviously, that's not correct. Okay, so there's some misinformation about out there. How bad is it? This is another excerpt from the press release. It's quite simple. The numbers do not add up. There are probably no more than 20,000 polar bears left today. And more like 25,000, probably a little bit more than that. The population down by 20 to 40% in 4 years. Not so much. It's actually up quite a bit. Science reckons they can multiply by less than 4% per year. Not so much. There's documented growth rates of more than 5.5% in Baffin Bay. Okay, so there's a lot of misinformation right here. But we allow 5% per year to be shot. No, we don't. The flat harvest rate is 4%, and a lot of places go lower than that. So this is the type of misinformation out there that I think can be really confusing to the general public as far as what is actually going on with polar bears. So let's continue on though. Let's talk about what we actually know and what we don't know in a little bit more detail about polar bears. I wanted to start off by presenting this as a cascade of projected impacts on polar bears. And it all starts with sea ice loss. And this information, these projected impacts are well documented in the literature. It's been published in a handful of papers. But it starts with sea ice loss. And with sea ice loss, we lose that key habitat for polar bears. That is going to result in reduced access to prey items because they do rely on it as the primary hunting platform. If they have reduced access to prey, that's going to lead to declining fat stores, deteriorating body condition. That's going to result in diminished reproduction, decreased survival. And of course, that's going to ultimately lead to decreased abundance. If you're not having cubs, and if you're dying off at higher rates, then ultimately your population is going to decrease. Okay? So that's what's projected to happen with polar bears. If we look at the circumpolar map, and just to get your bearings, this is North America right over here. We can see that the polar bear populations are actually divided up into 19 different populations. And several years ago, some colleagues at the USGS organized these populations based on similarity of sea ice dynamics. So they organized it into 4 general regions. We have in purple, the divergent ice ecoregion, which is where ice is receding away from the coastline and up into AB, the Arctic Basin. We have the blue, the convergent ice ecoregion, which is just the opposite. Ice is moving into the blue areas. We have the seasonal ice ecoregion in green, which includes Baffin Bay, Data Strait, Foxe Basin, Western Hudson Bay, Southern Hudson Bay. That's largely where I've worked. In those areas, it's just like the name suggests. Those areas have seasonal ice, and they have part of the year without ice. And when there's not ice around, those bears are confined to land. It's fine. It's not fine anymore, but it used to be fine. And then finally, we have the archipelago in orange there. And that is an area that's anticipated to be buffered against some of the initial impacts of climate change. Okay. So let's take a little bit more close look at this. So we start off with this sea ice loss. What do we actually know about sea ice loss? Now, there are 2 aspects of sea ice loss. We have changes in the quality of the sea ice habitat, and then just overall changes in the duration of the sea ice habitat that's available. So the first image I'm showing here is from Environment Canada. And this is really showing when breakup occurs over portions of North America. So as we mentioned on the previous slide there's going to be a lot of spatial and temporal variability. Not all polar bear populations are going to respond the same to the impacts of climate change and to those changes in sea ice dynamics. And this illustrates that. This shows, okay, there's very different sea ice, what we call a breakup date, when the ice sort of recedes, breaks up, leaves the area. We see in yellow and orange, those are early breakup dates. And as we move into reds, pinks, and purples, those are later breakup dates. And the blue there is actually an area where the ice remains throughout the year. It's the minimum sea ice extent. Okay, so that's one half of the equation. The other half of the extent of the ice-free season is, of course, if it breaks up, then we got to wait for it to reform again. And this is a map, another map from Environment Canada. And this is showing how sea ice formation differed in December of 2010 from the 30 years previous to that. So if we see red and more brightly colored reds, that indicates to us that there's significantly less ice than relative to the average. And if we see blues and more intense blues, that indicates that there's significantly more ice than average. Not a whole lot of blue there. Not a whole lot of blue there either. So what this is telling us is that sea ice breakup, or sea ice freeze up, is occurring later in the year than it did relative to the 30 years prior. So this is another little aspect of sea ice here. This is some research that was just published a few months ago by a colleague at the University of Washington named Kristen Leiter and her team. And what they really were looking at is the impacts of these changing sea ice dynamics, not just on polar bears, but on a whole variety of marine mammals in the Arctic. And one of the pieces to this was to document these broad scale changes in sea ice dynamics. So what they found was that the summer season, which they defined as the spring season retreat to the fall season reformation there, over the past 30 plus years, that has increased, that summer season has increased by 10 to 12 years up to more than, or 10 to 12 days up to more than 20 days, with the exception of the Bering Sea and that area between Alaska and Russia. So there's no doubt that the sea ice dynamics in Arctic are changing. They're changing quite rapidly. In general, they're outpacing the forecasts of how we thought sea ice would be changed. So that's not good for a sea ice dependent species. So we've got the sea ice component in place now. Now the second component of this is reduced access to prey. And as we mentioned, polar bears rely on sea ice as a hunting platform. And if you're a polar bear, you need about, an adult polar bear, you need about 45, 50, give or take, seals a year to sustain yourself for that year, to maintain a healthy body, healthy physiology, etc. Okay? If you're confined to land during the ice-free season, you're going to be losing about a kilogram a day. So when we talk about the extension of that summer ice-free season by a couple days on the front and a couple days on the back, that loss can add up to quite a bit with just a few days here and there. And that deteriorating body condition might make you less able to survive. It might make you less able to reproduce. And that's really where the issue is. Okay. So one of the ideas that's been tossed about by a handful of folks, and it's gotten quite a bit of press in a variety of outlets, is can other types of food augment polar bear diet and sustain populations in the changing Arctic? In other words, if those bears are spending more time on land, can't they just change what they're eating and use that to offset whatever losses they have from seals? Now remember, sea ice is the hunting platform. They're true carnivores, unlike other bears. They eat seals, they might eat walrus, beluga, a few other things, but they primarily eat ring seals across most of their range. Okay, so we would be transitioning from seals, a few polar bears eat walrus and other things, to things like this, Arctic char. There have been lots of reports, anecdotal reports, on polar bears foraging in snow geese habitats. Berries. I've personally seen polar bears with berry stains on their bones that indicate that they were eating berries and had pooped them out and were going about their merry way. I've also seen polar bears that have scavenged on caribou. They're not going to take down a caribou, they can certainly scavenge on them. So unfortunately, there is insufficient evidence at this point to suggest that any of these food items can offset the losses that they're going to sustain pre-season and the deterioration of habitat quality. So that's kind of an unfortunate result of that, but that's the general consensus among scientists. There are going to be a couple divergent views there, but that is the consensus among the polar bear scientific community right now, is that these losses cannot offset what bears are going to lose in terms of seals. Okay. So we've got sea ice loss, we've got reduced access to prey, and then again, that's going to ultimately result in declining fat stores and body condition, diminished reproduction and survival, and again, if you're not having cubs, you're not surviving, ultimately there's going to be a decrease in the population, decrease in abundance. Okay, so I lumped those last three items together because we could spend a whole heck of a lot of time talking about different case studies and looking at this, that, and the other, but there are a few other things I wanted to get to today. So let's just lump those together and look at sort of the big picture again of the Arctic 19 populations of polar bears. So that's what's projected to happen. What do we actually know is happening right now in terms of climate change? Those are areas, SB is the southern Beaufort Sea, that's in partially in Alaska, partially in Canada. WH, western Hudson Bay, that's the most well-studied polar bear population in the world, in Baffin Bay. Those are three populations where it seems like we're seeing some quite significant impacts of climate change. Western Hudson Bay and Baffin Bay, the data is the recent data is a little bit more equivocal. I'll get to that in just a second. But southern Beaufort Sea, there's a recent study that was just finished up, and it suggests there's been quite a decline in abundance associated with declines in survival. So southern Beaufort Sea doesn't look like it's doing too well right now. Okay, so that's three populations though out of 19. These yellow areas here are not showing signs of climate impacts, or the data are a bit more ambiguous. We can take a look at the Chukchi Sea up at the top next to SB. Those areas are right next to each other, and although the Chukchi Sea bears there have experienced a huge increase in the number of reduced ice days. It's increased by about 44 days over the last 3+ decades. That's a big change for a polar bear. The bears, their body condition, their recruitment indices, they are not reduced at all. So those bears are hanging in there just fine. Relative to the southern Beaufort Sea, which, as I mentioned, those bears are really struggling right now. So there's something going on there that, although those bears are both experiencing some pretty large-scale changes, bears in the Chukchi Sea are able to deal with it a lot better than bears in the southern Beaufort Sea are right now. Might be attributable to differences in productivity, so there are more seals in the Chukchi Sea, or it might simply be a fact that, or result of the fact that this whole concept of ice-free days is relatively new in the Chukchi Sea, whereas bears in the southern Beaufort Sea have been dealing with it for quite some time. Yes.
And I know you were saying about losses, but isn't that the area too where they're seeing big changes in haul outs?
Yeah, there's some debate there.
Is there?
Yeah, but that's what I've heard as well. Yes. Yeah, so that's one example. We could go through a variety of these. I'll just point to one more here. The WH in western Hudson Bay and the southern Hudson Bay. Okay, so in southern Hudson Bay, we've seen declining body condition. There's some indication of declines in survival rates, but the populations remain stable there for the last 30+ years. Okay, so although these other metrics indicate maybe things aren't doing too well, the population itself is hanging in there right now. In western Hudson Bay, we could actually, sorry, I jumped the gun a little bit there, we could actually change that one back to yellow, because there have been 2 recent studies conducted there that suggest that actually that population for the last decade or so has remained relatively stable. That's attributable to the ice conditions remaining relatively stable as well. Okay, so it's a mixed bag, and then you throw in this equation over here on the right, and I've got a bunch of populations circled in red. The red means those are data deficient. We simply don't have enough information to make an educated statement about how those bears in those areas are actually doing right now. And my little blurb down here in the bottom, we have some significant information gaps for more than half of the defined polar bear populations right now. The current trend, which is 12 years centered on the present, so the 6 years prior and the 6 years projecting out in the future, is data deficient. So there are big information gaps right now. Okay? So we've got a status map that might look something like this. This is put out by the Polar Bear Specialist Group, which is a group of experts around the world that are basically charged with determining how polar bears are doing and answering important technical and management type questions. Okay? So we look at the gray areas, according to our key there, those are data deficient. We look at the yellow areas, those the Polar Bear Specialist Group at this point is continuing or considering to be stable populations, meaning they're not changing right now. Green is increasing and red is decreasing. I have no qualms with the southern Beaufort Sea. Those bears don't seem like they're doing too well. The BB and the KB, also in red down here at the bottom, Baffin Bay and Katy Basin. That's some old data, and that's based on some pretty old projections too. So we're doing some updated work now that will provide some better information, I think, from which to assess status there. Okay? So, in my opinion, as a biologist working on this doesn't unequivocally point one way or the other. Okay? We've got a huge information gaps here, but it seems like right now, in a lot of areas, polar bears are actually doing okay. It doesn't mean they're going to be doing okay in the future, but right now it seems like they're doing okay. There are a few areas where they're not doing okay. There's some other areas where they seem like they're doing pretty well. So, getting back to the misinformation then. It's one of the last quotes I'll throw up, no worries. So there are polar populations about which scientists still know very little, and the total number of polar bears worldwide remains uncertain. But the populations for which there is data together clearly point to a species in decline. This is a blog on Carbon Brief entitled Polar Bears and Climate Change. What does the science say? And when I look at that, I don't see anything to suggest that there is clearly a species right now that's in decline. Again, it doesn't mean they're not going to be declining in the future, but right now I think that's somewhat of a misleading and inaccurate statement. Okay? So, point being, just be aware that there's a preponderance of misinformation out there, so you got to be careful about what you're reading and what you're digesting and what you are holding to be true or not. Okay, any questions about how polar bears are doing right now? What we know, what we don't know. Okay, let me get a drink of water. All right. So what are some of the challenges that we face in polar bear science and management? Well, Polar bear management itself, there are multiple competing perspectives, as I've alluded to several times here. And that's really created somewhat of a management conflict, largely between Aboriginal peoples in the north and some of the scientists that are coming from different perspectives. And it's what we would call a wicked policy problem. What does that mean? That means it's like an onion. There are many layers. They're all entangled. It's really nasty to try to figure out and parse apart what's going on and how to reconcile these different stakeholder perspectives. There are challenges. So with all these multiple competing perspectives, there are challenges in the management and the development of policies. And there are also, as a result of this, strained relationships that have devolved, unfortunately, between some Aboriginal peoples and some scientists. So it's created an atmosphere that's not entirely fun to work in sometimes. It's very politically charged. So the real issue, though, is how can we reconcile these different stakeholder perspectives to incorporate these different ideas, these different knowledge bases into one management plan that is acceptable to everybody and that is scientifically grounded. It's not an easy solution. So what are some of the factors here that are contributing to this? What makes, in my opinion, what makes polar bear science and management particularly challenging? Just from the management perspective, not from the technical perspective. I'll get to that in just a second. I'm going to go back to this. I already mentioned this. Polar bears are charismatic megafauna. They really evoke that emotional response in people, and people get kind of excited and fired up about that. There's also the political scene. And polar bears, like it or not, they're symbolic of climate change, and it's made the job of biologists quite a bit more difficult to just do science because there's going to be politics interjected into a lot of what we do. It's really resulted in a politicization of science. What else? Well, there are some big cultural differences here, and I'm not going to go through all the examples of this, but the one I will mention is there are different wildlife values and there are different social values here. And what do I mean by that? Well, as scientists, we might think it's acceptable to go out, fly around in a helicopter, to dart a bear, to immobilize it, put it to sleep, put it in ear tag, put it in tattoos, take a bunch of measurements, put on a satellite collar so that we can follow where it's going. That's the way we learn. That's how we want to gain information. For Aboriginal people, that is completely unacceptable and in direct opposition to their beliefs and their value systems. That's disrespectful to the animal. You do not do that. So that's certainly contributing to this as well as a key cultural difference. There are multiple legislative mandates, and this extends through various levels of organization, from international mandates, things like the Convention on the International Trade in Endangered Species, federal mandates, whether you're in the US or in Canada, or in Greenland and Denmark, and there's provincial and territorial mandates, and there's also Aboriginal mandates there. So trying to make sure that you're accommodating those different regulatory frameworks can be pretty challenging as well. The management system in Canada in particular is pretty darn complicated. There's multiple tiers, and again, you have to try to accommodate those and make sure you're going through the process correctly. And I think this bottom point here is quite challenging as well. Defining the stakeholders. What do I mean by that? Who really gets a say in polar bear conservation and polar bear management? Certainly the people in the north do. What about us in the south? Do we have enough of a stake in polar bears to be able to, should we have a voice in polar bear conservation and management? I'm not saying yay or nay, but when you're talking about trying to define who gets to make the decisions about polar bears, it can become a little bit murky. And finally, the different knowledge bases that are out there. There's the Western science, or the scientific way of looking at things, and there's also, for Aboriginal people, what we might call local knowledge or traditional knowledge. And that's knowledge that's passed down through the generations, through the culture, that can be shared and used to inform polar bear science and management. Okay? So there are differences in those knowledge sources. There's also differences in the science itself. We might look at the same piece of information and interpret things quite differently. So the classic example I have of differences between science and differences versus traditional knowledge is in sightings, increased sightings of polar bears on land. Okay? I mentioned there are seasonal ice populations, and both science and traditional knowledge are going to report seeing more and more bears on land. Now the interpretation of that is quite different though. Science is going to tell you, yeah, you're seeing more bears on land because they're spending more time on land, so there's more opportunity for encounters. And they're also getting themselves in a little bit more trouble because they're hungry, so they're venturing out and doing things they otherwise wouldn't going into communities, checking out hunters' camps, etc. Okay, so that's why you're seeing more bears. Traditional knowledge, however, is going to tell you, no. We're seeing more bears because there are more bears. It's not that complicated, guys. Okay, so trying to parse apart those different pieces of information and those different interpretations can be quite challenging as well. Okay. So those are all some of the challenges that I think are quite important in the context of polar bear management. How about polar bear science? What are some of the technical challenges that we have to deal with as biologists when we're trying to go out there and get information about polar bears? Okay, I highlighted in there the Foxe Basin population. This is where I've done a lot of my research over the last several years. It's a big area, and I think you can gather that just by looking at the size of that. 1.1 million square kilometers. It's a big number. What does that equal? And something that might be a little bit more relatable. Texas plus California. Okay. So we're trying to figure out, get information about bears in an area that's the size of Texas plus California. Do we want to bring it a little closer to home? Well, Minnesota is about 225,000 square kilometers. That means we've got not one, but 5 Minnesotas. Okay. Polar bears can cover the area of 5 Minnesotas. It's a big area. Not only that, the Arctic is not a well-populated area. And I've highlighted Nunavut here with the very light tan color. Nunavut covers about 22–23% of the landmass of Canada. Across Nunavut, there are fewer than 30 communities, and there are about 30,000 people. That makes it one of the least sparsely populated places on the planet. From a wildlife perspective, that's okay. That might be a good thing. But if you're trying to do research, what that means is there's not the logistical infrastructure there to facilitate you doing your research. It makes it a heck of a lot more challenging in terms of planning. Nunavut's one side of things. Let's take it to the extreme, though. Greenland. I had the privilege to be involved in some discussions back in November about how do we get information about polar bears in eastern Greenland. Eastern Greenland, the population of polar bears, spans the entire east coast of Greenland. For reference, that is larger than the Foxe Basin population, so it's more than 1.1 million square kilometers. There are, I think, 2 communities. There's a couple of old military bases there, and that is it. You've got a massive area, you're dealing with really difficult logistical situation, and you're trying to get the information about polar bears. So it just makes, the remoteness plus the size makes it really complicated to do work in the Arctic. Now again, this is the picture we typically think of with polar bears, but in the seasonalized populations, polar bears can be confined to habitats like this or this. It's a big area to study regardless. And because it's such a big area, that means you're either working out of this, or more likely you're working out of something like that. So you're going to have to work out of an aircraft when you're studying polar bears, most likely. So that's a twin otter, and that's a helicopter there. We use a variety of aircraft depending on what the job at hand actually is, what the objectives of the study actually are. So that's great. You have to use aircraft. You have to be able to access these far-flung areas at quick speed because you've got a huge amount of area to cover. And these bears are at very low densities. Unfortunately, there's not a gas station around the corner. So that means you have to bring up all your fuel, you have to cache it out on the land. The upshot of this is planning for polar bear research takes years and years in advance to make a successful study. And then you also have this going on. Okay, this is, what I'm trying to convey here is inclement weather. That's the type of situation where you can still make out the horizon here, but that's pretty flat white. What I call flat light, where it's not a bright sunny day, it's not easy to see what's going on, it's not perhaps the funnest situation to be flying around in. So this unpredictable weather can totally foul up the best laid plans, and it's completely out of your control. One last thing here. So I'm showing you this nice pretty map. We've got these nice lines all laid out. If only it was that easy. So when you go up to the Arctic, this is probably not going to be a big surprise, but there's not big red lines painted on the ice. There's not big red lines painted on the land. Okay, so you don't step, oh, yep, there's the line, going from back to back to straight. It's not the way it works. If it was the way it works, polar bears don't care. They're going to go from point A to point B. And in fact, I've been referring to these as populations. These are actually what we call subpopulations. That they're afforded that term because there's a lot of movement among the population. So bears might go from Baffin Bay to Davis Strait. They might climb around the corner there into East Greenland, vice versa. They might go over the top Baffin Bay, Kane Basin, up to the Arctic Basin, down to the Barents Sea. So they're moving all over the place. And these These boundaries are based on good information. They're based on capture and satellite telemetry and genetics, all kinds of good stuff, but they're not discrete boundaries. Bears still move all over the place. Okay. So in sum here, we've got massive areas, we've got extremely remote areas, we've got crazy logistics, we've got bears that are all over the place, we've got inclement weather. What does that add up to? Big bucks. Polar bear research is not cheap. And coming from the sea turtle world, where research is really cheap, it was quite an eye-opener to look at like the cost of actually trying to do work in the north. Okay. Any questions about this before we move on?
What's the, you got 19 areas there, what did, you say they move around a lot, but is there any estimate of population for each area to any given point?
Yeah, for example, I can just give you a for instance here. Most of my work, when I talk about new methods, it's actually about getting at that question right there. How many bears are there in a particular area? So in Foxe Basin, for example, that's a good healthy population. There's about 2,600 bears there, give or take 500. In Western Hudson Bay, there's about 1,000 bears. In Southern Hudson Bay, there's about 1,000 bears too. Yes?
How do you count the bears?
I will get to that. Other questions? If I can postpone you for just a minute. Okay, so I've tried to set the stage here for some challenging situations as far as getting scientific information about polar bears and some challenging situations for the management of polar bears. Now, I want to talk a little bit about how do we know what we know? What are the methods we use to study polar bears? Now, historically, the primary method that's been used to study polar bears has been what we call mark recapture, or capture mark recapture. And this is what it involves. It involves flying around in a helicopter, hanging out the side of a helicopter, darting a bear. There's the bear circled in red. Sorry, I had to really zoom in on this picture, but that's the bear circled in red. The bear is immobilized, it goes to sleep, and then we can land, we can put in ear tags, we can put in a tattoo, we can collect our measurements, our various samples, etc. So here's some other nice pictures. The bears are asleep. That's a colleague of mine. That looks like a mom and a cub there. And there's the picture I continue to use because they're pretty cool. So that's the way this works. And the math behind it is pretty complicated, but in its simplest form, it's just ratios. And this capture-based work has been sort of the standard for most polar bear work for the past several decades. And much of what we know today has been facilitated by capture-based studies. Okay, so much of what we know that includes things like population sizes. How many bears are there in a certain area? Reproductive output. How many cubs are they producing? How well are those cubs surviving? How well are the adults surviving? How well are the teenagers surviving? Growth rates. Do bears grow faster or slower in particular areas? Energetics. How many resources do they need in a given year to be able to sustain themselves? The diets. Are bears in particular areas eating more ring seals versus more harp seals versus more beluga? Whatever. And the movements, okay? So this is not all based on just tagging, but capture work itself facilitates collecting the samples, putting out those satellite collars, collecting other information that facilitates a variety of studies. But there are challenges associated with capture work as well. First of all, in Nunavut, again, that's where I've primarily worked, these inventory cycles, these periods in which we study a population, leave it alone for a while, and come back and study it again, about 15 or more years can elapse between those periods, and a lot can change in those 15 years. So, unfortunately, right now, given the speed at which the climate is changing, that rotation really lags behind the environmental change. So there's a need for more efficient techniques and alternative techniques that allow us to revisit those populations more frequently. High costs. I think we've demonstrated that polar bear work costs quite a bit of money to conduct. And finally, I also mentioned these cultural differences here, and in particular, the wildlife and social values here. Capture work is inconsistent with public opinion in the North in general, and with traditional values. There have been also some concerns raised about, well, capture work, sometimes they don't sample across the entire area, so that means we don't capture bears from across the entire population. Maybe we only focus here, but we ignore this area in between. What impact does that have on the results? And then there are also concerns about, does capture work harm bears? And are they safe for consumption? There's been data to suggest that no, capture work probably doesn't really harm bears, and yes, after a day or two, polar bears are safe for consumption if you're a local hunter and you shoot a bear that's just been tagged and immobilized. but there's still those concerns out there. So if we're not catching bears, what are we doing? Well, number one, we can do something called genetic marker capture. And I'll talk about each of these in a little bit more detail in just a minute. Aerial surveys and remote sensing. Okay. So these are alternative techniques that I'll get into here in just a minute that are going to better reflect northern values, meaning that there's not those concerns about the differences in cultures. And they might improve the efficiency, meaning that they might allow us to revisit those populations more frequently, but they provide less detailed information for us. So it changes the whole management framework for us. Okay, so I'm going to briefly touch on each of these. The first one I'm going to mention here is genetic marker recapture. And this is a pretty cool technique. This is, I'm actually, a large part of my job right now is analyzing some data from those two populations, Baffin Bay and King Basin. This is a big project that was just completed last year, and it was based on this technique here. So you're still flying around in a helicopter, you're still darting a bear, but instead of putting the bear to sleep and putting tags in and such, you're just taking a little biopsy sample. Okay? That's the biopsy dart up there at the top. There's no needle there to inject drug, it's hollow. So you shoot it in the rear end or in the shoulder. That orange line there, that's the biopsy dart relative to the bear. Okay, so the helicopter's right over the head, took the picture, boom, there's the dart, there's the bear. The bear skedaddle on, you can land, pick up the tissue. You can take that tissue then, genotype it, and that tells us the same information we would need from tagging, right? So it says, okay, this is a bear, this is the first time this bear has been captured, or this is a bear and she was recaptured 3 years ago. And this is, so we know she's still alive. So this gives us the same type of information that we would need to build our population models, which is what things like abundance and survival and reproduction are all based on. Okay, so this is a pretty exciting technique, I think. It gives us really detailed information without actually physically capturing bears. Aerial surveys. So with an aerial survey, what you're doing then is you're still flying around in a helicopter, you're flying around in an airplane, but you're not darting bears. You're just observing them. And based on their distribution across the landscape, you can do a little bit of math and figure out how many bears there are. So I'll quickly try to talk you through how this works. This first technique we use is called SIGHT-RESIGHT. And it's a variation on the same type of population models we would use for physically capturing bears. And what you do here, the important part is who saw what bears. So if myself and 3 colleagues are sitting in an aircraft, we want to know who saw which bears. And that's the key piece of information that allows us to do this. So, for example, if we're flying along here, let's say that the guy seated in the front of the aircraft saw this bear circle in yellow. And then let's say that both the guy in the front and the back saw this group of mom and 2 cubs far off to the right. And then we'll say that only the guy in the front of the helicopter saw that bear there. So we use that piece of information, who saw what bears, to estimate how many bears that nobody saw. It's just ratios. It's a little bit more complicated than that, but it's largely just ratios. Okay? So that's the bear. And because we know we've surveyed this area here, we know how many bears there were in a particular area. That allows us to estimate density. And then we can extrapolate that across the areas we didn't survey. Does that make sense? Sort of. The other technique we use is called distance sampling. This is a little bit more intuitive. It's based on the premise that it's easier for us to see objects that are close to us than objects that are far away. So as we're flying along, the key piece of information we're looking for here is how far those bears are located from our flight path. So we're measuring those distances, and based on that information, we can fit a mathematical model to that data and estimate how many bears were within that surveyed area, within those green lines that we missed. That bear right there. Again, we have a defined survey area. We know how many bears were there. We estimated the bears we missed, calculate density, and extrapolate it across the unsurveyed areas. That's really how aerial surveys work. So my 3-year-old at home would tell me, "Daddy, that's a weird rainbow we just made there." But in fact, what I'm trying to illustrate here is that we try to fly in areas where we know there are the most bears, because that gives us the best estimate of how many bears there are. But we want to make sure that we cover those areas where there still might be a few bears, but there are lower density. So those are the different colors that we're trying to use there. So the different colors represent different intensities of sand. What type of information can we get from an aerial survey then? Well, we get a nice estimate of how many bears there are in a particular area. And we also get cool information about where the bears are located on the landscape too. So this is information from 2010. Each of those little red dots indicates a polar bear sighting. So in this particular year, we saw a little over 1,000 bears across Foxe Basin. And then remember the population estimate from Foxe Basin was about 2,600 bears. So the next technique I'll mention here is remote sensing. And this is kind of the cool, fun technology related stuff. So when I say remote sensing, yeah, we're remote when we're doing an aerial survey. We're flying a few hundred feet above the ground, but we're not satellite remote. With satellites, we're several hundred kilometers above the ground. Think about Google Earth when you're thinking about satellite imagery here. So I have a colleague at the University of Minnesota. Her name is Michelle LaRue, and she's done a lot of work on remote sensing using this high-resolution satellite imagery along the lines of Google Earth to figure out how many seals there are in particular areas. So this is a paper she published a few years ago on whale seals. And you can see this white area here, that's all sea ice. And the black dots, those are actually seals that they confirmed from the ground. This is some other work she's done. I don't see any seals there, but I do see a big brown splotch on the ice. She's done a lot of work on penguins. And those are not penguins, but that is penguin poop. So you can also see penguin poop from satellite imagery. And based on the size of that penguin poop, you can infer how many penguins are there. So it's pretty cool. Okay, so we thought, hey, why can't we do this with polar bears? Polar bears are a big animal. They're certainly a lot bigger than penguins are. They don't poop like that. But I think if we're looking in those seasonal ice populations, where we've got a white bear and a dark background, we just turned it on its head from the whale seals. We're not looking for dark on white. We're looking for white on dark. We might be able to make this work. Okay, so we selected this area in Foxe Basin for a couple different reasons. Number one, we knew there were high polar bear densities that were on this small set of islands. Those orange dots there indicate the number of bears that we sighted on those islands in 2010. Number two, we knew that they were excellent sighting conditions. As I mentioned, we're looking for white bears on a dark landscape. There is absolutely no snow on the landscape in the late summer and early fall, and there's no ice. So this is the only white thing, save rocks or patches of gravel on the landscape, that is going to be the size of a polar bear, is a polar bear, minus the rocks. But we'll get to that. Okay, so that's the type of environment we're looking at. That's a picture taken from about 400 feet in the middle there. So you can see that that bear really stands out on that bright background. The other thing that we had going for us in this particular area is there's low topographic relief. What do I mean by that? The landscape itself is very flat, so you don't have to worry about these huge mountains and so forth. That's typical of the landscape. Doesn't get much better than this. We figured if we can't come up with a way to use satellite imagery in these areas, then it's just not going to work right now. So the idea is really simple. This is not rocket science by any stretch of the imagination. We're just looking for white dots in the dark landscape. So we got white dot, white dot, white dot. That one's a little bit tough, but you'll have to take my word for it. There is a white dot there. Okay, so we thought, okay, now we know we have rocks on the landscape as well. How are we going to figure out what's a rock versus what's a polar bear? Well, rocks typically are not going to move. So if we compare successive shots, polar bears are not going to be in the same spot, whereas a rock is going to be in the same spot. Really simple. Okay, so how does this work? So we've got our image again, our three dots are circled there. And let's look at this bottom image. We see in the top left-hand corner there, white spot, no white spot, probably a bear. Bottom right-hand corner, white spot, no white spot, probably a bear. Top right-hand corner, white spot you can kind of make out. Lo and behold, that white spot is still there. So that's a pretty good indication to us that that's not a rock. So what we did here then is that's all well and good to say like, oh, we can see this, and we were pretty confident that this is actually bears. But we actually flew out to a variety of sites then to confirm that yes, that is a rock on the landscape, whereas that is something that can be confused with a bear, versus no, there's nothing there that can be confused with a bear. So what we came up with is a population estimate that was very consistent with an aerial survey estimate, and we also found that our ground truthing, going out flying to those sites and comparing what we thought was there with actually what was there was really accurate. So that suggested to us, hey, this can be a pretty promising tool for monitoring polar bears in certain conditions. So there are some limitations associated with that, but we can't tell what's a cub necessarily, and we can't completely synchronize the satellites with our actual surveys on the ground. So there are some limitations there, but as an initial step, we thought this was pretty promising. So then this led to the next question: can we use satellite imagery in more challenging environments? What do I mean by more challenging? Well, how about sites that are actually kind of mountainous, or at least hilly, and have snow and ice patches? I'll cut to the chase here. No, right now you can't do that. That's why. Okay, so this is a more mountainous area in a more northerly climate. And you can see those are mostly ice flows, I think, meaning they're chunks of ice that have washed ashore. That's the coastline right along there. But it's completely impossible to tell what's going to be a piece of ice versus what's going to be a polar bear, because the ice is going to melt or the ice is going to wash away as well. No ability to distinguish. Not going to see a polar bear there either. That's characteristic of a higher mountainous type area as well. You have unpredictable snow cover. No chance of seeing a polar bear there. There are a variety of other issues associated with this. So then the natural question might be, okay, you're using black and white imagery. Why are you not using color imagery, or what we might call multispectral imagery? In that picture in the top, the two black arrows are pointing to polar bears. And when we try to look at the color imagery, and the color's a little funky here, but that's the best way to look at it in this multispectral imagery, you can see that they really wash out. The bears really don't stand out anymore. And why is that? That's because the resolution, the pixel size, changes. So it goes from quite small to quite big. And we don't have that resolution in place any longer to be able to discriminate what's a polar bear versus what's not a polar bear. Can detection be automated? So this initial study was based on me and a colleague sifting through hours and hours and hours of staring at a computer screen, looking for little white dots, and then comparing and seeing if there's another white dot. That gets kind of tedious, and it was a little bit challenging to maintain the attention span there. Okay, so can we do that? Can we teach the computer to do this for us? To a certain extent. So this is kind of a funky picture here, but what we did is we had the computer subtract image A from image B to try to point out those areas that were different from one picture to the next, one satellite image to the next. The yellow, that represents the areas, those areas that were the same between images. The red and the green and the purple, those all highlight areas that were present on one image but not on another. So the answer to this is, yeah, we can eliminate a lot of the image, but we're still going to have to manually go back through and try to catalyze what is and is not polar bear. So, what is the future of satellite imagery? Well, it's actually, I think this is really exciting stuff. There's a brand new satellite that launched last August. It's called WorldView 3. And there have also been some regulatory changes in the US that have provided us access to this higher resolution imagery. And what it's going to do is going to change the resolution from 50 to 60 centimeters all the way down to 30 centimeters. And that means a 400% improvement in resolution for us. So whereas a polar bear might have been 6, 8, 10 pixels previously, all of a sudden we're talking about a polar bear being 25, 30, 35 pixels. And in terms of being able to see what's a polar bear and what's not a polar bear, and being able to teach the computer to do the work for us, that presents a lot more opportunity. Okay. Along with that, that's the black and white image, but this color imagery is also going to improve quite a bit. So I think the technological improvements are going to really change the landscape in terms of what we're able to do with remote sensing, with satellite imagery, in monitoring polar bears and other wildlife. And the last thing I want to mention here is drones. Okay. So we tried this in 2012, and it ended quite spectacularly with a crash from several hundred feet at about 60 miles an hour. The drone blew up. This time, we tried this in Churchill with some colleagues this past October, and it went quite a bit better. This is the platform we're using. It's very small. This is not like a big Predator drone or a military-style drone or something like that. It's quite small. It's about yay big, but it's really impressive performance. It can handle the Arctic conditions. It can fly down to 30 or 40 below in pretty steep winds. So it's a pretty impressive little machine. And the idea with this is not to say, okay, all of a sudden we can just fly a drone out for hours and hours and hours and let it collect all the information for us. The technology is not quite there yet, what's commercially available to us. Nor is the regulatory framework there yet. Okay, so the idea with this instead was to say, okay, we know that the satellite technology is coming along. It would be really great if we could get some information about the spectral signature of polar bears. What makes the polar bear, in terms of its coloration, different from its surrounding environment, to be able to be ready when the technology improves. So it can inform the larger satellite imagery question. I'm showing you an image that was collected in Basin Bay back in 2010. You're flying at 500 feet. It's a belly-mounted camera from a twin otter. We're looking for a polar bear. Okay, it's kind of challenging. I don't know if anybody can see it, but that's it right there. Okay, so it's tiny. We're pretty high up. You can zoom in on it. Okay, now you can see it a little better. So what we're really interested in, this is just normal light. We haven't made any modifications to the picture. What we're really interested in with the drone, with this particular study then, was, okay, can we brighten it up a little bit? Can we find something unique about it that the polar bear itself that allows it to be distinguished from its surrounding environment? Because now, I mean, you can see a polar bear there, but it's a little bit challenging, particularly when you go back to that resolution. It really pops now. Okay, so that's what we're trying to find. So we flew this drone around. We, meaning not me, but the guys who are actually pilots and know what they're doing with this stuff. In western Hudson Bay, right around Churchill. And it was great because there was a live video feed, so you could actually see. We'd spot a bear on the ground. We were working out of the Frontiers North Tundra buggies, which is pretty fun too. Spot a bear from the ground and then go up, hover several hundred feet above the ground, and gradually go down and collect imagery of the polar bears. And that's the type of imagery that you collect. So that's pretty cool. That's from a couple hundred feet up. It's a very high resolution camera, and you can see there's a longitude cut there. Just kind of bells it down. Now, one of the other things we were using here, it wasn't just a plain camera. We also used what's called a multispectral camera. So this allows us to isolate the spectral band instead of align with the satellite imagery. Remember, we're trying to use this to inform satellite imagery, get ready for the technological improvements of satellite imagery. So if we isolate a couple bands from that multispectral camera, that's what we get. Okay, so these are the same bears. They've shifted a little bit. This is with just a very high resolution Nikon multispectral camera. They're at the bears right now. So we've isolated green and blue. And those bears, they're starting to stand out a little bit. This is a work in progress, but I just wanted to share some of these preliminary results with you. This is a little bit more challenging, but there's the bears up there. So we can keep you posted on this one. So what does the future look like for polar bear science and monitoring? Well, although the historical framework has been capture-based, and there's still a lot of utility for capture-based work, there's also a real need to embrace these other techniques and sort of add them to the toolbox. So there might be certain situations that require capture work. There might be certain situations where something like satellite imagery, particularly in those really far-flung areas, prove more beneficial and can give us at least a little bit of information, which is better than having no information. Okay. So with that, that's about all I have for you today. Thank you very much again for listening to me here for the past hour or so. Lots of people to thank here for my funding over the last several years. Lots of colleagues as well. I didn't want to try to list anybody because I was confident I would forget people. With that, thanks again, and I'll be happy to try to answer any questions you have. Thanks.
Is there anything to negate that maybe the sea ice might accumulate more in the future and it just goes the other way and it gets older?
Not that I'm aware of. There might be some hypotheses out there, but I think the consensus is that it's not looking so good right now for sea ice. Yes?
There is a catch-22 question, because you're working on the sort of creation of baseline data, to make good decisions going forward. Is there any work sort of varying that to modeling? I realize modeling is only as good as the data you put in it, but would that help you identify areas you'd want to study? I think that USGS data, I think, was based on some modeling.
Yeah. So that Southern Beaufort Sea paper that I actually referenced, the new one that shows the bears aren't doing too well there. Yeah, that's based on some pretty intensive modeling. And there's a lot of projection modeling that goes on right now in terms of not only sea ice, but how polar bears are going to fare in response to changing sea ice dynamics. wanted to stay away from that
Yeah.
tonight. But yeah, there's absolutely a lot of modeling. And a lot of my work, I've talked about this in the context of abundance estimation, but this genetic market capture work, we're trying to get abundance estimates and survival and so forth. That's going to be bringing in some different environmental components as well to try to figure out, okay, how does the change sea ice impact recruitment or impact survival or whatever. Does that answer your question?
Yeah.
Yes.
I was wondering, is heat sensing available at all, or is
Yeah, that's a great question. And there has been some work that's been done on that. It's forward-looking infrared, mounted on aircraft, and essentially polar bears are so well insulated that really the only thing you can see are their eyeballs and their nose.
Oh.
So it does have an application though. For example, on the North Slope of Alaska, with all the oil developments and so forth going on there, they can use those forward-looking infrared cameras to identify bending sites to try to stay away from those, because those are fairly well insulated and they will accumulate enough heat to be able to detect. So, yeah. Other questions? Yes.
Have you tried doing photography when the sun's at a low angle using detection technology?
So there is, I showed you the pictures that were taken from the belly-mounted camera. Some of that work was collected when the sun was at a little bit lower angle, and we have a colleague at Environment Canada who's working on an algorithm to be able to automate detection with those, and part of what he's using is just what you mentioned there, is the shadow information. Yes, other question?
What is your hunch about the data deficient in the US population?
Try to stay away from speculating too much. I really don't know. There's one area there, the abbreviation was BS, Barents Sea. Unfortunately. And there's been some work conducted there in terms of abundance estimation. There's also a lot of other research that goes on there. I think there have been some pretty substantial sea ice changes. I don't know if it's been enough to manifest itself in terms of like a populational decline. But, I don't even want to hazard a guess as far as those areas in Russia where we know literally nothing about there.
Is there a lot of hunting on there?
It's outlawed, but I think in some areas, yeah, there is some illegal hunting that goes on. There is a black market as well for polar hunts. Yeah. Other questions? Yes.
Yeah, you see the bears moving more as conditions change a lot to the areas that you're showing that are bedrooms?
Yeah, there's been some genetic information that suggests there's been a large-scale movement of bears out of those seasonal ice areas up into towards that Arctic archipelago where all those islands are over the last several decades. Beyond that, there's not a whole lot. So, I mean, bears are not stupid. They're not going to stand around and just be like, oh, I guess I'm just going to start with that. They're going to try to make a living and move on to another area. But as far as like large-scale movements, that's really the only thing I'm aware of.
I saw a program not too long ago about due to the climate changes that now it's allowing the black bears to interact with the polar bears. Have you seen that?
I haven't seen black bears. I've heard about that perhaps in Newfoundland and Labrador, but certainly brown bears. And there have been several cases. Okay, no worries. Yeah, so brown bear range is expanding, and I haven't seen any brown bears in polar bear work, but there have been cases of hybrids. There's been cases of a second generation hybrid. I had a colleague who was working in the Arctic archipelago who said he saw a grizzly bear, brown bear, whatever you want to call it, about 60 miles out on the sea ice, which is kind of bizarre, but it seemed like it was trying to take advantage of seals as well. So yeah, there are definitely more opportunities between bears in some areas spending more time on land and polar bears, and then brown bears moving in, more opportunities for interaction there. From a cultural perspective, I think it's really interesting as well, because the brown bears in Nunavut are seen as a complete vermin, nuisance species. People don't like brown bears. They're seen as troublemakers and tearing up camps and causing all kinds of trouble. Whereas polar bears, although they're dangerous and people tend to be somewhat scared and very respectful of them, they're held in much higher esteem. So there's quite a differentiation among those two species culturally. Yes?
With aerial surveying, is there a decrease in reliability of data? I mean, wouldn't it be highly fluctuated on what you can see versus what you don't, what you're assuming you don't see, but actually is there, and like survey, like sample size?
Yeah, with any of these statistical methods, there are a lot of assumptions and that go along with them. And you know, we try to design our surveys to be as strong as possible to be able to meet those assumptions. Of course, with that capture work, there's a whole lot of assumptions that go along with those as well. I think any of these techniques can be really useful as long as you work really hard to try to meet those assumptions. And if you can't meet them, you're transparent in acknowledging, okay, you know, we don't exactly know what's going on here. We did the best we could with it, basically. So I don't think that aerial surveys are any more or any less able to provide good information than other techniques are, as long as you meet those assumptions. Was there another? Yes?
Do you take the cups?
With the genetic marker capture with the biopsy darting, no. We don't dart those because they're, depending on the season, they can be pretty small. With actual physical capture work, yes, those are tagged.
Because you know, they have with the moose now are saying, or they're saying reports have that moose are not protecting their babies anymore. They're just kind of letting them go because they've been tagged.
Okay.
And the mothers don't, don't want to be with them anymore.
Okay.
I wasn't thinking that was the same way with the polar bears.
I honestly wouldn't be able to make an educated statement about that. I'm guessing there might be instances of that, but I think by and large, polar bear moms will hang in there. And when the female is put to sleep and the cubs are put to sleep, if they're in different locations, bring everybody back together so that the cub's not half a kilometer away. It's actually right next to mom as well.
How long do the cubs stay with the mother?
Depends. Typically 2 years. So they're born in December, January. So they'll be what we call a cub of the year that first year, a yearling that second year, and then the following spring is typically when mom will give them the boot, and then she'll try to have a new litter of cubs. Some areas, if it's not a good hunting area, not particularly productive, they might stay with mom for that second year or the third year as well. So then we'll call them a 2-year-old. There are other areas, particularly Hudson Bay a few decades ago, where mom would actually give them the boot in the first year. So they would be a cub of the year, and then the following spring she'd kick them to the curb. Because it was so productive that she could afford to do that, and the cubs could afford to do that because they could make their own money. Yes?
Do you know if the lifespan of polar bears has increased and decreased or reduced?
I don't think there's, the way we would categorize that is in terms of survival rates. And they're pretty variable across the Arctic depending on what area you're in and what time period you're talking about. In places like the southern Beaufort Sea, certainly survival has decreased. It's stabilized recently, but for a period in the mid-2000s, it was much lower. And that was linked to some bad ice years, basically. So it's really going to depend on where you are and what time period you're talking about. Other questions?
How long do polar bears live?
Good question. 30, 35 years would be about the maximum life expectancy. That's a very senior bear, though. Prime age adults, right around 8 to 18, 8 to 20, something like that, 6 to 20, somewhere around in there. I would say that most aren't going to live beyond about 20, 25.
Is that the same way with the brown bear?
Don't know. Other questions? Yes?
You mentioned a number of species of food sources.
Yes.
Are any of the populations defined by a major food source?
Are they defined by major food sources? Yeah, that's a good question. If you remember back to my map, there was a population called Davis Strait. It's around Newfoundland and Labrador and continues up into Baffin Island and over to Greenland. Primarily eat harp seals there. Across most of the range, ring seals is the primary prey. Davis Strait is a good example where it's largely harp seals. When you get over into the Beaufort Sea, it's almost exclusively ring seals, whereas in, say, Foxe Basin and Hudson Bay, there's a lot more diversity of prey items there. So a bear could take a bearded seal. Ring seals are fairly small by seal standards. Bearded seals, the big adults, are 500 pounds. Big males can take a beluga. Walrus, I was in Foxe Basin in 2012. I had never seen a walrus kill, and I saw 4 within 2 days. So, you know, yeah, maybe some things are changing in terms of the prey composition as well. Questions? Okay. Well, thank you guys very much. I appreciate it.
Thank you all for coming again. Hopefully we'll see you next month. We're having a continued bear discussion on June 22nd with Dr. Dan Marcellus. So we're going to hear your various questions next month as well.